talk here. I'm happy to introduce Tesseract, and the talk is going to focus on Tesseract, our piece that enables machine learning within our container infrastructure. Just to kind of give you an agenda, we'll introduce what the problem is. I'll introduce the deployment scale at PayPal and how we can apply machine learning for fleet management and container infrastructure in there. We'll do a deep dive into time series forecasting because we're trying to figure out levels of forecasting to make sure that we're efficient at all points of time, and then we'll open it up for some questions. So we are growing pretty fast. We're growing at scale and we're growing with momentum. What all of this growth brings is our infrastructure needs to be able to support that same kind of reliability, the same kinds of assurance that we have our customers experiencing every single day when it comes to making a transaction on platform, sending money to someone, or making sure that they're not being defrauded on our platform, right? So that essentially for us translates into hundreds of services behind the scenes, both ML enabled and non-ML enabled, and with all sorts of flavors, right? So we have around 1,300 mid-tier pools, 300 frontier pools, and everything. They come in all sizes and shapes. So the pool sizes are different. The traffic that different services experience is different. The latency requirements that each of them have is going to be different, and we have several availability zones that we want to make sure that our service is available to everyone all the time. And the key aspect of all of this that I'm going to focus today is that we are on-prem and on cloud. So what does that intersection kind of give us? Like what is different about operating in the cloud a little bit, right? So the cloud, is like your Aladdin's lamp, right? You ask for something and you get it. You want more compute, you get more compute. You want more memory, you get more memory. You want better responsiveness, you can get there. But it is also like a Pandora's box because you're paying for every single thing, right? So as you're scaling, as you're adding, you can get quickly into the snowball effect where everything is working amazing, but your operating cost has also increased pretty significantly. And this is an area that we are trying to understand and essentially improve our efficiencies, both in terms of operational and cost. For us, our traffic is dependent on the users, right? And users have a typical traffic pattern, right? Folks using the platform tend to use it more during the day and less during the night, right? And even though we have a lot of global presence, so we get different peaks of days and nights all across the world, but there is still a strong pattern. So what this enables us to do is think about cost from the perspective that can we add capacity to our services when they need them, right? What this allows us is play with that cost dynamic, right? If we think about our traffic and you're sizing it up, then you can think of, hey, where do I want to be? I can be at my daily troughs, and that is what I get into committed capacity for on a cloud environment, which is typically 3x, 2x less expensive than having your on-demand capacity where you ask for something and you get it and you pay for how long you use it for. Committed is you're going to be using it for a longer time period, so you're committing for a year or so, right? You get better prices. Luckily for us, we have this dependable pattern that we can leverage, right? And find a sweet spot of, hey, I want to be committed at this level, but I know that my traffic grows in this particular way. If we apply machine learning and deep learning to get better and better at figuring out when I need what I need, I can be a little bit more clever about how I leverage the cloud, right? So what do you do with an auto-scaling environment, right? Once you start auto-scaling, you have the opportunity to optimize. One is, of course, your cost, right? So like I said, during our peak hours, you can always use on-demand and then let it go later. But we also have the opportunity to use committed capacity that we already have. We can prioritize different jobs to be running at different times, right? And in different zones. So a simple example would be something like batch jobs, right? We can control when batch jobs run so that we can run it when our overall site demand is lower instead of having it prop up whenever it wants, right? And through intelligent prioritization, we can prioritize services that enable payments of during a time of crunch, right? And kind of ease back on something else that might not be critical. So the goal of right sizing, and that is where I'm taking this towards, is to have a way in which we have our core metrics, so our whole platform reporting things like, what is your CPU usage, what is your memory usage, what is the throughput, right? And feed that into your machine learning models that end up predicting, from what I've been seeing, this is where I think it's going, right? Provide us insights, provide us priorities, provide us ways to place certain kinds of services so that they work better and more efficiently on a single VM, right? That brings us to a hybrid decision system where, we have a bunch of data points coming in from our infrastructure saying, this is my alerting on CPU, this is the kinds of errors I'm seeing, what is my next stage? So we can think of it as, I am at this stage right now, this is the state of my system, how do I take it either towards an optimized state, or if I am in a state where I'm dangerous, how do I at least reduce my risks, right? So we have a lot of leeway to kind of see how can we make that sense. And finally, using machine learning, we'll have the ability to make predictions, right? We want to be smart of how we want to operate in a cloud environment, right? So we can project into the future and say, typically this is what March looks for me like. This is what August for me is typically how busy it is going to be, and not just months, right? It can be days. Mondays can be busier than Fridays, or Wednesdays can be low, right? So all sorts of mixtures. With that, let me kind of get one step deeper into the machine learning aspects of thinking about time series prediction. Time series prediction is, for me, of all the machine learning problems that we typically tend to solve, one of the hardest, right? Because if it has so many external factors coming in and a lot of noise, that makes it hard for us to reliably predict further and further we go into the future. And typically when you come into a time series prediction problem, especially, it's dominated by statistical methods and less so by machine learning methods. There's just so much more work that's gone into time series prediction from a statistical perspective, right? So think about seasonality, trends, non-linear trends, predicting multiple steps into the future, change points that create unusual events coming in, right? And we do have, most of the people that I've spoken to, right, end up choosing something like Arima, and more recently, FB Profit has been one of those packages that you plug in and you start being like, okay, hey, this works for me, right? But when it comes to our kinds of data, where we see a lot more jitter, right? And we see a lot more unique behaviors, a lot more acceleration that does not flow from day to day, right? So applying these methods out of the box does not give us high resolution forecasting. So if I want to gauge what is my CPU demand going to be in the next 15 minutes or next 30 minutes or 1 hour, it's hard to get these statistical models because the capacity to learn is limited, right? And of course, you can start getting into deep learning methods. And here, you get into the opposite problem. The capacity is huge, but it's hard to get them deployed for one time series that I want to predict, right? We want to generalize the problem enough to kind of say, hey, these are typical CPU time series from these services. Is there a common trend or common theme to learn from these, right? And that is where some of this is moving into, and a lot of the methods that we use are hybrid methods, a mixture of statistical and deep learning methods to get into predictions. So one of the methods that we're currently exploring is NBeats. It was one of the it didn't participate in the forecasting competition M4, but I think in M5, which was recently announced, they did have a lot of hybrid methods with statistical methods and NBs combined to score high on some of these aspects. And I want to kind of dig deeper a little bit into why it makes sense for us. So NBeats is a forecasting architecture where we have a way to break down the problem into simpler problems. And typically, when we get into deep learning and machine learning, we get into this area that how do I do interpretability of your problem, right? And this is where it has one leg up. So we can break the problem into residual blocks so that each residual block deals with a smaller problem. So the main forecasting problem can solve some of it. Whatever is the residual, the second block goes for it, and the third block. And furthermore, we can break it down into things like trend, seasonality, and something that's more specific for your time series, right? So you break it down, you're still using machine learning, but you're still creating these interpretable blocks that will help us add up those small predictions and get to our final forecast, right? And for us, we can optimize this further to kind of say, because we're looking at capacity, we want to be sure that the peak volume that we experience, we want to be careful at predicting that. So we can change the objective function so that we are focused on making sure that our predictions at the peaks are better than somewhere else. So once we have this in place, right, we get into these reactive models for us to start making predictions on what should the capacity be for any service at any point of time, right? You typically get this straight out of the box from Kubernetes, let's say, right? It's just going to look at your CPU and be like, I want to keep the CPU between 40 and 45%. What does that mean? But here, the ability of introducing machine learning is, I know where we'll be 30 minutes from now or 1 hour from now, so let me be more clever and have a better sense of what the sizing should be. So that's how forecasting fits into our problem of right sizing. Right. So typically the way we have an overall view is we don't just look at the forecast, but also we have our alerts and metrics within the pipeline that basically is giving us an observability view into the whole process, right? So what is the current state of our systems? What is the alerting states? How many CPU alerts do we have? What is the growth that I'm going to be experiencing in the next 30 minutes? And using all of this information, we have a hybrid decisioning system that will be like, okay, given the hotness that I'm seeing on CPU, given that the traffic might actually be going lower, I have the opportunity to optimize at that point to say, okay, I don't really have to worry about the situation. It is going to ease itself out because the traffic is actually in a downward trend, right? But if we think of the opposite situation where the traffic is growing and you're seeing things running hot, then we have the opportunity to preempt and add capacity sooner than what would be normal from a system that is not aware of this total kind of state, right? I think I'm running out of time, so just to say how this whole thing looks out, right? We build an observation state, right? Which includes what is the current throughputs, what is the kind of acceleration are we seeing for our throughputs, what is the state of the whole system, and we also have a sense of multiple availability zones working all the time, right? We want to be sure that we are resilient, so sometimes an availability zone can go down and all the traffic that's there in that availability zone can come into us, right? So we have that opportunity to kind of stay one step ahead of all of these processes so that we leverage the cloud for that Aladdin kind of lamp box where we get whatever we want when we want, but we are also very careful about when we ask for something, and we are also ready to give back some things when we know that we don't need it. Right. Yeah, with that, happy to take questions on some of these aspects.